Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And we are having part two of this question. Okay, let us go through the question very fast. We are having experiments, 3 of them, where zinc is reacting with each of these acids. And the mass of zinc is given. So the mass of zinc which was put in the flask is 1.6 grams. And zinc is in excess. And the question comes, what does the question say? This is for experiment 1. It says, experiment 1 was carried out at 30 degrees. The molar volume of the gas at 30 degrees is 24.5 cubic decimeter. Calculate the total volume V of the gas liberated. How do we approach this question? Okay. We are going to approach it stoichiometrically. We are having our zinc, and our zinc is reacting, experiment 1, with the sulfuric acid. And what we get out of this one is going to be zinc sulfate and hydrogen gas. Next part is going to be balancing, but it looks like the equation is already balanced. So what does stoichiometrically means? That we are going to use this equation to come up with the answers. We must not forget that this is our limiting reagent. Yes, that is it. And we must also know that our interest is in the gas given out. So under this circumstance, what do we have? We are going to have our normal table. At this side, we are having our sulfuric acid. On this side, we are having our hydrogen gas. For sulfuric acid, let us look at here. The number here is 1, the number here is 1, so the ratios are 1 to 1. Okay. After that, this is what we have to know, that if for sulfuric acid, we know the concentration, which is 0.2 moles per cubic decimeter. What else do we know? We know the volume. What's the volume? It's 100 cubic centimeter. So when you convert it to cubic decimeter, you get 0.1 cubic decimeter. Having concentration and volume gives you number of moles, which number of moles are calculatable through this equation. So after substitution, this is what we have. So what is here? Number of moles are now known. It's going to be 0.2 times 0.1. Okay, let's get it. So now after this, what do we do? You go to our mole ratios. It is 1 to 1. What does that imply? The implication is that the number of moles of hydrogen gas liberated is 0.02 moles. Okay. When you reach this stage, what do? You convert number of moles to volume using the equation which is well known, which is V over Vm. Number of moles is equal to volume of gas liberated over molar volume of the gas at that given temperature. So number of moles is going to be 0.02, and the volume of gas liberated is wanted, but we know our molar volume, which is 24.5. At this level, what do? We have now the volume given by 0.02 times 24.5, giving you, yes, so giving you this volume in cubic decimeter, 0.49 cubic decimeter. Okay, so that's the question, that's the answer.